Right, for question 2, essentially this was answered pretty well according to the lecturer who marked it. Just some points to just address over here. Okay, so assigning things using the Carn-Engel-Prelog rules, I remember we're moving one atom at a time as we move along. And so if we're assigning one as the highest priority, we're going to carbon over there, hydrogen over there, carbon and carbon. So the hydrogen must have the lowest, so we can immediately put that in. In fact, hydrogen's always going to be the lowest, so it's just very easy to do that. Okay, so then this carbon goes to another carbon, this carbon goes to another carbon, and this carbon goes to sulfur. Sulfur has a higher priority than carbon, so this must have been carbon number 1. Now the difficulty I think with a lot of people where they made mistakes was which one of these gets the higher priority. And in terms of the rules, the way you can look at it is, you see this carbon is connected to 2 carbons and a hydrogen. All right, this carbon is connected to 2 carbons because of the double bond and a hydrogen, so there's no difference. Then we move on, and as we move on, this carbon is connected to 3 hydrogens and another carbon going backwards, whereas this carbon over here is connected to 2 hydrogens and it's doubly bonded to the carbon as we go backwards. So this one, the double bond, has the higher priority over the single bond over there. So that gets priority 2 and this gets priority 3. All right. The next one should have, in a very similar fashion, should have been easy enough to look at. Carbon, 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 no difference. Carbon goes to oxygen, carbon goes to carbon, carbon goes to oxygen, carbon goes to nitrogen. So going to the carbon must have the lowest priority. Then we got the 2 oxygens, which have a higher priority. Oxygen is molar mass of 16, whereas nitrogen is 14. So the nitrogen loses out to the oxygen, so it must be number 3. And then we've got a carbon single bonded to oxygen, carbon double bonded to oxygen. That's going to win out versus the single bond, so that'll get number 2 like that. All right, so hopefully that made sense. These questions over here, just the comparisons. When I set up this test, I made these questions just very basic principles. I wasn't trying to trick you or anything. This was just, can you see that how these compounds are related to each other? So these two over here, there's been a complete inversion of the chiral centers. The OH is up there, the NH2 is down, OH up, NH2 is down. These are mirror images of each other, and they will be non-superposable with each other. So these must be enantiomers. Then the next question over here, you see the structures look almost identical to each other, except that here the phenyl group is up and it's down over here, and over here they are both up. So not all the chiral centers have been inverted, and so because of that, these are not mirror images of each other, and they must be diastereomers. All right, so then the next one, although the double bond is going via this one being the E and this being the Z double bond, so it's kind of looking like, ooh, double bond switching, it must be maybe a diastereomer. What you had to look out for is that the OH was also shifting position. These two would have very different names in terms of the way that where the phenol group is located, and this has to be a constitutional isomer because of that. And this one over here, compared to this one over here, what you need to notice is actually, if I took this and just did it upside down, that, all right, have a look, is the same as that. All right, these two compounds were identical to each other. Okay, so that was the end of question.